I hope you all had great time working with the assignments. The key takeaway here is whenever you allow the user to input the data, make sure to validate it before submitting it to the network. With that, you can lower the chances of your software behaving unpredictably. Unlike in movies, if your audience can predict the future scene, maybe it's considered as a bad movie. But if your software behaves unpredictably, it won't be considered as a thrilling software. It will be considered as a badly written software. So as far as possible, let's make sure our software works predictably. Now this generates a transaction signature and an ID. We need to submit this transaction signature to the network, which will have this corresponding ID, by the way. And remember, this whole thing can be done offline. The generation of transaction signature can be done offline totally. The only thing we are requesting from the network is sequence number. But if you know the sequence number of your account, you can just replace it manually without connecting to the network. Maybe pass it as a user argument from the command line. That way, the entire script runs offline, and then submit this generated transaction signature to another script which is connected to the network. For the sake of this video, let's assume that you have written a script which is connected to the network which accepts transaction signature from the users. And whenever we are accepting input from the user, we need to verify the user input. So let's do the same in this video. And one more thing to note here is if someone gets hold of your transaction signature, they can't derive the secret out of it. All they can do is submit this to the network, and the payment, in this case, it's a payment transaction. So the payment will end up going to this destination, and they can't change the destination address using this transaction signature. Okay, so it's safe to submit this signed transaction over the network to any scripts. Okay. Now let's see how we can verify this transaction signature. So whenever we think of verifying something, we have always used the XRPL account lib library, wherein we have utils methods. Let me show that to you. The package has utils which has methods like isValidAddress to verify, that is validate our address, isValidSeed to validate family seed, isMnemonic to validate mnemonic kind of secret. So similarly, you might think there is another method to verify signature, which is write. But then it takes 3 arguments, that is the message hex, the signature which we have generated already, and the public key. Public key, as the name implies, you can share it publicly. There is another corresponding key which is called secret key, which you should not share with anyone. Okay. But the problem with this method is we need to work on our payload to convert it to the message hex. That is, we need to binary encode it, reorder, that is sort, hash it, etc. before submitting it to the verify method. Let me show that to you. This, the first argument, we need to work on it before submitting it. So in order to reduce all the hassles, we have another package called verify XRPL signature specifically done for this, which is very simple. Just import the package and pass the transaction signature as an argument. That's it. The only difference is if it's a multi-signed transaction, you need to pass in the R address as second argument. We will look at multi-signing in a separate video. So for now, let's see how we can verify our transaction signature. So first thing is to install this package. So let me copy this. And do npm install. Let me even save this to package.json file as dependency. Now let's import the method we want from this library, which is verify signature. Okay, it's not from this package, so let's replace it with verify XRPL signature package name. Now let's get down here and remove this. Let me have a constant called verify result, and then pass the transaction signature to it. As you can see, the second argument can be undefined. Okay, That's the second argument is only used in case of multi-signed signature, that is transaction signature. So let's output the verified result. So let me widen the screen a little bit so that we can see the output. Okay, so let's concentrate on this output, that is signature valid, yes, true, signed by. It outputs an R address which should be associated with the family seed we input to this script, which you can see here. So this is the R address corresponding to this family seed we input to this script. And is this signature valid, that is signed by the R address? Yes, true. Is it multi-signed signature? No, false. If it's multi-signed, make sure to pass the R address, that is the R address associated with the secret key which you use to sign this transaction. Okay. But let's look at multi-signing in a separate video. For now, this is the syntax to verify a signature which involves multi-signing as well as signed by single user. Now the interesting thing about this verification is it takes place offline, that is your script need not be connected to the internet because it's purely mathematical thing. So generating the signature and verifying it can be done offline. Only to process it, that is to submit the transaction to XRP ledger and process it, we need to get connected to XRP ledger. So we shall do that in our next video. So this is how we generate the signature and verify which R address actually signed it, that is who signed it and if it's valid, that is signed by the same R address. Once the signature passes the verification, the next logical step is to submit it to XRP ledger and wait for the response with an ID which matches the ID generated by our signing method. So let's look at that in our next video.